Hello everyone, Assalamualaikum warahmatullahi wabarakatuh and good day to every one of you. Welcome to my video. So basically this is a continuation on the chapter 3, which is induction machines. Okay, and then in this video we are going to continue our lesson on the topics on how to determine the parameter for the equivalent circuit of the induction machines by using several tests. Okay, so the test will be no load test and also the block rotor test. Okay, alright. So how to determine the parameter of the equivalent circuit model? So basically there are three different tests that we are going to see. The first test is a no load test. Okay, so the no load test basically is similar to the open circuit test that we had done on the transformer. So I need you to go back to the chapter 2 and review the video and also the slides to see the similarity between the open circuit test and also the no load test. Okay, so basically for the no load test, the purpose is to determine the value of the magnetizing reactance and also the core resistance, which is the RC and also XM. Okay, so the second test is the block rotor test. Okay, so the block rotor test basically similar to the short circuit test that we perform on the transformer. Okay, for the block rotor test, we are going to determine the value of R equivalent and also the X equivalent, where the R equivalent is equal to R1 plus R2 prime, and then X equivalent is equal to X1 plus X2 prime. Okay, and then for the third test is the stator DC resistance measurement test. Okay, so whereby by performing this test, we are going to determine the value of R1. Okay, so based on the R1, you also know the value of R1 and R2 prime, then only you can determine the value of the R2 prime. Okay, so here is the equivalent circuit model for the induction machines. Okay, so if you refer to the equivalent circuit model, you know that in order to determine the value of RC and also XM, we perform the no load test. Okay, so in order to determine the value of the R1, R2 prime, X1 and also X2 prime, we perform the block rotor test. Okay, so for the value of the R1, we can determine based on the stator DC resistance measurement test. Alright. Okay, now let's have a look at the first test, which is the no load test, or we can also call it as an open circuit test. Okay, so this is the equivalent circuit of the induction machines when we performing the no load test, which is the open circuit. When we say open circuit, meaning that we open the rotor pipe. Okay, we open circuit here. Okay, so when it's open here, what you can see, no current will be flow through this branch. Okay, so when it's open circuit here, we can just assume we can just remove this thing, everything. Okay, and then we can also assume that the value of RC plus JXM is much greater compared to the R1 plus JX1 for the case of induction machine under the no load test. Okay, so that's why we can also neglect this part. So, and then after that, the equivalent circuit of the induction machine during the no load test will be equal to here. Okay, we just remove the rotor part because it is open circuit here, and then because of the value RC and also XM is much greater compared to the R1 plus JX1, so that's why you can just short circuit here. Right? Okay. Under this no load test condition, the motor is supplied by the rated line-to-line voltage V1, and then the no load current and also the no load input power is measured. The no load input power includes the magnetizing and also the rotational losses. Using the measured value of the PNL, of the INL and also the V1, we can calculate the value of RC and also XM, provided we neglect the value of R1 and also JX1. Okay, so that's why here it said that using the measured values, the admittance and the resistance are calculated if the winding leakage impedance is neglected. So we neglect the value of R1 and JX1. Okay, we use the value of PNL, INL and also the V1 in order to determine the value of RC and also JXM. Okay, alright, so basically this is the formula on how to determine the value of RC and also XM. For the RC, you can just use the formula of R equal to V squared divided by power. Okay, so the value of RC will be equal to the voltage across the RC. Voltage across the RC is a V1 squared divided by the no load input power that measured by the wattmeter. Okay, and then in order to calculate the XM, first of all, you need to find the value of admittance first. Okay, Y will be equal to the current divided by the voltage. Okay, so the current is I no load, and then the voltage is equal to the, you need to, because since the induction machine is in the 3-phase configuration, so that's why you need to divide your V1 divided by square root 3. Okay, alright, and then once you find the value of Y, then, or the value of your admittance, your Y, you can determine the value of your XM by using this formula. Okay, XM will be equal to 1 divided by Y squared minus 1 RC squared square root. Alright, so this is the method for the no load test. Okay, so next we will see for the Rotolock test, or we can also call it as a short circuit test. Okay, so if you refer to the circuit of the equivalent circuit of the induction machines, okay, so for the short circuit test, we just short circuit the rotor part here. Okay, alright. Okay, and then in this test, the rotor is blocked so that the motor cannot rotate. Okay, so that's why we call it as a Rotolock. We block the rotor, we lock the rotor so that the rotor becomes standstill. Right. So the motor is then supplied by the reduced voltage Vs. Okay, and then with the reduced voltage Vs with lower frequency voltage around 15 Hz only during the Rotolock test. The voltage Vs and also the current Is and also the input power Ps are then measured under this condition. Okay, in this case, the RC and also the JXM can be neglected because of the reduced power supply. Okay, because you reduce the power supply, then you can neglect the RC and also JXM. So basically, this is a equivalent circuit of the induction machine under Rotolock test condition. Okay, when you short circuit at your rotor part, and then you assume your RC, here just now you have RC and XM, but you neglect it because you reduce the voltage supply here. So that's why you just only left with R1, JX1, JX2 prime, R2 prime divided by S here. Okay, so by applying the Ohm's law to this kind of circuit, and then by using the value of the the measured value of your Vs, Is and also Ps, you can find the value of R1, JX1, JX2 prime and also the R2 prime over S. Okay, so by using this formula, you know that the Z equivalent, or you can ZBR is equal to the block rotor. Okay, so the Z equivalent is equal to the voltage supply divided by the current. Okay, but again, because since this is the 3-phase, so that's why you need to multiply your current supply with the square root 3. Okay, Vs divided by the square root 3 Is, then you can find the value of the Z equivalent. Z equivalent will be equal to the R1 plus R2 prime divided by S plus your JX1 plus JX2 prime. Okay, and then for the value of RBR, okay, you can use the formula of R equal to P divided by 3I squared. Okay, so the PS is actually the power that measured during your Rotolock test, measured by the wattmeter. Okay, and then the I supply, also the current measured. Okay, and then you can find the RBR will be equal to R1 plus your R2 prime plus S. Based on this formula, you can find your R equivalent. Okay, and then for the X equivalent, S equivalent will be equal to your Z equivalent minus your R equivalent. Okay, so X equivalent is equal to X1 plus X2 prime. Okay, alright, so this is all the formula that we can use in order to determine the value of the R1, JX1, JX2 prime and also the R2 prime by using the Rotolock test. Alright. Okay, next we go to the third test, which is the Stator DC measurement test. Okay, so for the Stator DC measurement test, we are going to use this test in order to find the value of R1. Okay, so for the Stator DC measurement test condition, first of all, the motor is supplied by the DC voltage between the two terminals. Okay, so if you refer to this figure, consider your 3-phase induction machines have three different terminals, which is here is your terminal A, terminal B, and also the terminal C. Okay, so this is the winding at your first phase winding. Okay, second winding, third phase winding. Alright. Okay, so the supply of V1 is connected between the terminal A and also the terminal B. So I1 is the current that flow through the from the supply through the first winding and also the second winding. Okay, the DC voltage and also current are also measured. So that's why here we can put the voltmeter across the terminal A and also terminal B, and also we put the ammeter in series with from terminal A to the terminal B. Alright. based on this connection, you can further simplify your circuit. Okay, so since you supply the DC voltage, so that's why your L1 and also here your second L1 can be neglected, can become short circuit because you apply DC voltage across the inductance. Okay, so here become short circuit, here also become short circuit. Okay, so this is the new simplified version circuit based on this connection. So that's why based on here, when you're applying your voltage your Ohm's law, you can find the value of R1. Okay, so by applying V equal to IR, you know that R1 will be equal to V1 divided by the 2I1. Okay, so this is how you determine the value of R1 for the equivalent circuit of the induction machine. So that's all for now. Thank you for your time. Thank you for watching my video. I'll see you in my next video. Okay, bye.